Alright guys, welcome back to Spring Boot Advanced Concept series. In this series, we will be talking about the most talked about architecture, that is the microservice architecture. So this is a very booming topic today, the concept of microservices, which is actually an architecture. So let us understand in this session, basically we will be talking about how to build it rather than like how to code it, right? So let's go ahead and see how microservices work first, and then we will also compare that with the monolithic applications, that is the monolithic architecture which we used before. So now before we get into the code part and do all the implementation, let us first understand exactly what is the monolithic architecture and what is a microservice architecture. So let us first consider that we are building any, let's say, an online shopping app, okay, an online shopping website or an online shopping application. So once we are building this, at that time what we do is, if suppose we are using a monolithic architecture, so we are building a big application, and this big application uh, will have some of the modules into it. So what all modules this one monolithic architecture, that is a shopping application, contains? It can contain something like a user login, it can contain something like the product catalog, right? And it can contain things like the cart, it can contain orders, it can contain the payment, it can contain the delivery and all, right? So as for now, these are enough. Okay. So one of our application, the shopping application, the shopping app contains all these modules, right? So once we have all these modules in a monolithic architecture, what happens is everything, see, all of this will be in one single code base. So we can consider everything is in one code base, okay, and there will be only one database for this application, and there will be one deployment. Okay, so this is what we did before. Whenever we were building the applications, we used to have modules into it, and the modules, we created all that module as one single unit there. Okay, so what problem we started facing in monolithic architecture? Let us understand the problems that we faced in a monolithic architecture. So imagine if the payment fails, if this module, the payment module, fails. So what has to be done? Since there is only one single deployment for all these modules, we have to redeploy the entire application. So that is problem number one. That is, if one of the module fails, the entire application has to be redeployed. Now let us consider the second problem here. Let's say the product catalog. Okay, so that means there are a lot of users, they are trying to just search for the product. They're not making orders, they're not adding it to a cart and all that, but they are searching for the product. So this particular module has a very heavy traffic. So if obviously when there are more users, we call it as traffic. So when we have a lot of traffic on one of the module of this application, what we have to do is we have to upscale it, right? That means we have to scale this. So we cannot scale it, we cannot improve it. What do we mean by scaling? Now the scaling can be of two type. It can be a vertical scaling or horizontal scaling. That means when we talk about scaling, we either improve the hardware. That means we let's say if it is hosted on a 4 GB RAM machine, we can go and upgrade it to 8 GB RAM machine, likewise. So upscaling can be done. But since everything is a part of one single application, we cannot separately upscale only the product catalog. What we have to do is we have to scale the entire application, not just the product module. So this is monolithic architecture. So if you want to understand it in one liner, monolithic architecture is, let's say, monolith equals to one big application containing everything. Okay, now that's what monolith is all about. Everything is in one single unit, one code base, one deployment, and one database. And if there is a problem in any one of the module, we have to redeploy it. If the traffic is there on one module, we have to scale the entire application. So these are the problems that we have seen in a monolithic architecture. So once we started seeing these type of problems in applications, then what we thought of is, why not split these modules into a separate project altogether? And splitting those modules into separate projects itself is the concept of microservices. So microservices are nothing but what? Uh, Instead of one big application, we split the modules into multiple services. Okay, so now let us understand what we do with this the modules that we had, like user login and all that. So now what we do is, instead of putting up into one single unit, we create it separately. Like there will be a user login created separately, there will be a product service created separately, there will be a cart service created service separately, there will be an order service created separately. Similarly, there will be a payment service created separately, likewise. Fine. So here we split them into smaller services, like we call them as user service, and then we call things like the cart service, we have the product service, then we have the order service. Okay, we call them as services. And we will have what? The payment service, the product service. So this itself is the microservice architecture. What we have done is, we have split them into multiple smaller services. Okay, now what would be the advantage of having the microservices rather than just having uh, a monolithic application? So instead of having a monolithic application, if we have a microservice architecture, at that time scaling would be easy, right? So how scaling becomes easy? That is, if suppose there's a traffic on the product, we can only upscale this instead of upscaling everything. So microservices are like many small independent services working together. So since they are independent of each other, if the card service fails, then what we can do is, we can redeploy only the card service rather than redeploying the entire application. Okay, so microservices solves those two problems that were raised in a monolithic architecture, where since there was only one database here, the advantage of having the microservices is that each of the service can have its own database, and not just the database, even the type of database can be different. For example, the card service can work on MySQL database, whereas the product service can work on the Mongo database. It's all possible. Okay, so now let us take a real-time example to understand the concept of microservices and the monolithic application, monolithic architecture, in fact. Imagine a restaurant that has one kitchen, and in that one kitchen you cook everything like pizza, burger, biryani and juice. You cook everything into one single kitchen itself. Now if the kitchen closes, that means all the services, that means everything stops. You don't cook pizza now, you don't cook burgers, you don't cook biryani, you don't serve juices, everything is closed. That is monolithic architecture. Now think of microservice architecture like a food court, where there are different shops for pizza, for burger, for juice and for biryani. These are now different shops. Now imagine if the juice shop closes, then what about the other shops? The other shop can still be functional, right? So other shops still work. If you want to go ahead and buy a pizza, you can buy a pizza. Since here the it's not it's not one single kitchen, it's a food court where we have separate shops working independently, right? So that's how microservices work. They are smaller parts of the same application itself, but they are independent. Fine. So let's understand the key differences before we move on to the code part. In a monolithic architecture, it is one big application, whereas microservices, it is many small services. Monolithic has one database, whereas microservices can have multiple databases. And monolithic architecture requires a single deployment, Whereas in microservices, each service can be deployed separately, so there is independent deployment here. And in monolithic architecture, it will be hard to scale the application, whereas in a microservice architecture, it will be easy to scale the application. That means easy to scale the service. And monolithic architecture, it is very hard to maintain, whereas in microservices it is easy to maintain. And in monolithic architecture, one failure can affect the whole application, whereas in microservices, if any of this fails, like for example, if the payment service fails here, it affects only to the payment service, rest all service will work as perfectly as possible. Fine. So that's how the architectures differ, the monolithic architecture and the microservice architecture, where monolithic architecture is a single large application where all modules are tightly coupled, whereas in microservices, they are small independent services communicating in the API, communicating via the API, and they are all loosely coupled. Fine. So that way, microservices brings us a lot of advantage. Now what we are going to do is we will be implementing these microservices into our application. So microservices, as we discussed, they are small independent Spring Boot application now that does one specific task. So each service is assigned with one single task, so that even the programmers can focus only on that particular part here. So even the coding is easy, as well as the entire architecture gives us a lot of advantage. So let's go ahead and see microservices in action. Now, to be very frank with you, microservices are nothing but what? A Spring Boot application. Fine. A small independent Spring Boot application that does one specific task is called as a microservice. So let's think of creating two microservices and let the microservices communicate. So here, if you see the microservices thing, the example that I showed you for a shopping application, let's take this, the product service and the order service, and let's build that. So let's have a product service, and then let's have an order service, where the order service is going to fetch the products from the product service. So that means there is a communication between these two services, and this service, the product service, is kind of what, this is the service that gives the data. Okay. And let's call this as the provider service, and here this order service is gonna receive that data. So service that calls the provider service, so let us call this as consumer service. And what are the services that we are building? We are building the product service, and we are building a order service. Okay, so these are the two services that I'm thinking of building. So both, obviously, since it is a microservice architecture, so both will be two different Spring Boot project altogether. Okay, and these two services will communicate with each other, right? So the product will come into the order. So these services, they talk through what? Using the uh, REST APIs, through an HTTP APIs. Okay, so they talk through something called as the REST template. Now, what is this REST template, and why do we use it? Why do we use it? I think you already got to know that. That is, the REST template will be used for the communication between these two services. And what is it? What is the REST template? It is a Spring class. Okay, so a REST template is a class, built-in class in Spring, that is used to call another micro service. So it is used to call another microservice. Whenever you are using a REST template in a microservice, you can call another microservice into it. Okay, so here we will be using a REST template. So do remember that part. A REST template will be used to call a microservice. So let us first build our product microservice, and after that we will build a order microservice. Fine. So two microservices we will be creating, and we will let them communicate with each other. Fine. So for that, let's go ahead and go to the code part. So for that, we have to go to the start.spring.io, and in the start.spring.io, let's give the artifact ID as demo hyphen, instead of demo and all. Let's call it as the microservice ms hyphen product service. Okay, so let's just call it as a product service, and let's call this as com.example dot the product service. Fine. So this product service and the order service both will require only two of the dependencies. One, the web dependency, obviously for the RESTful application development, and the second one is the Lombok dependency I would like to include. If you remember that in the previous session we have talked about the concept of Lombok, which reduces a lot of boilerplate code for us. So let us generate this microservice, the product service. Once we generate this, let us generate one more service and call that service as the order service. Okay, so we have the product service created. Now create the order service with the same dependency. So com dot example dot the order service is what I want. Okay, let's generate that. So once we are done with that, what we can do is now we can simply import these things. Okay, so let's go to the downloads part, and here we have the product service. Let's extract that, and first we will just extract the product service. We'll complete the product service and we'll come back to the order service. Let's import the product service now. So from the downloads we have the product service. Let's import that. Done. So once we import this product service, since we have the Lombok implemented here, not much to be done. So let's create a model first, which is nothing but an entity class first. So I'll put it into a model package. So you can call it as a model, you can call it as an entity. As for now, I don't have any Spring Data JP implemented here, so I will just simply call it as a model. So what model it is? The product model it is going to be. So I'll be creating a product here. So once we are creating this product class, what we can do is we can just identify the product properties, which is something like private int the product ID. Similarly, we'll have few more properties, something like a name of the product and also the price of the product. Okay, so the name of the product is gonna be of type string, and the price of the product, let that be int. Okay, so product name and then the price. So three properties I have declared here: the name of the product, and then the ID, and lastly the price of this product. Now generally we generate the getters and setters and the constructor and everything. So since we already know that we have implemented the Lombok in the previous session, and our ID is also capable of generating the Lombok stuff, that is we have set up the IDs as well, and just we will say a no argument constructor will be required for us, and an all argument constructor will be required. That's it. So I will not generate any boilerplate code here. That means I'm not gonna generate the getter, setters, to string, and the constructor without argument, constructor without argument, and all that. So nothing will be generated, just three annotation, and that's it. Now the next thing that I will do is I will create a controller here. Okay, so let's have a controller, and let's put that into the controller package. Let's call it as controller, and let's call this as the product controller. Fine. So we know that we have been creating controllers a lot of time here. Now we are going to just simply annotate this class with the rest controller. So let's annotate that with the rest controller. Now we have a rest controller, and we can also put up a request mapping so that we get a proper URL for it. So we will just call this as the product. Okay, so we have the product. The request mapping is for the product. Now I will not complicate this again. I will simply say that there is one method that's gonna call the product, and that will just give me the description, the details about the product. Okay, so for that what I will do is I will simply say there will be a method called as the get product. Okay, so let's create that get product, and this get product is obviously gonna return us a response entity of type product. So this is gonna be public response entity of type product. Okay, so this will actually give us the product back. Okay, so once it is giving us the product back, first thing what I will do is I'll just have a system.out.println just to show that the product service is being called. So let's call it as product service called, just a message on the console. And now I'm going to create a new product and return that product upon the call to this get product. Okay, So this will be a get mapping for us. So let's put a get mapping on top of the method here, and then let's create a product. So it's gonna be the product. The object product is equal to the new product. So whatever product that we want to create, let's say the product ID is 1, and then the product name and the price of the product. Let's say the product is what? Royal Enfield. Okay. So Royal Enfield, what? Maybe Hunter 350. So that's going to be our product, and then the price of the product. So let's give some price. Okay. So which is around 2 lakh rupees. So that's what I have given now. And now I have to return the response entity. So let's just do a return new response entity. So what is the response entity type here? The response entity type is going to be of type product, and the it is going to return us an HTTP status, which is going to be okay. Okay. So let's just return a product here. It will return as a product, and the HTTP status is gonna be okay. Fine. So that's it. We have simply created a product, and in the product service we have a product, and there is a function that returns us the product there. Okay. So let us run this particular, since it is a microservice architecture, we cannot let all the services run on the same port 8080. So because of which I will just be changing the port for this product service that I'm gonna execute here. So let's go to the application properties here. We have the product name as microservice product service. That's fine. That looks good. And now I will have a server port here. Okay, let's have a server dot port. That's gonna be 1111 or anything. Okay, so any product, any port number you can give. Now let's save it, and let's launch this service and test the service first, so that we can go to the next microservice. Now let's just simply run this as a Java application. So once we run this, we still will not have a product service being called until unless we call the get method. So let's go to the get mapping, and here I have written 1111 slash product it is. So it is the get mapping. So that should actually give me a product. That is the Royal Enfield product has to be given to me. So the product ID is 1 Royal Enfield Hunter 350 and the 2 lakh. So, and if I go to here, so it shows me that the product service is called. Fine. So that's one thing. I will let this particular service, the product service, keep running here. Fine. So let that keep running. Now we will be building the second service, that is going to be the order service for us. So one of the service is ready in our case, the product service, which is the provider, which is going to provide what? It is going to provide this product detail, that is product ID 1, name and the price. Fine. So let's now have an order service that is going to consume this type of product. Okay. Now let's import that as well. So I'll go here and import this. Yeah, first of all, I have to just extract that. Let's go back to the downloads and extract the order service. So I'm gonna extract it now. Done. Extracted the order service. So once I have extracted the order service, I will go and import the order service now. So let's import it. And existing Maven project, let's browse and go to the downloads, and here is the order service. So this is what we want to import. Fine, let's just finish this off. So you can see that the order service, which has almost the same dependency as the product service. So the first thing in the orders what we are going to create is, obviously we are going to consume a product. So when we are going to consume a product, we should have the same model here in the order service as well. So let's go ahead and create a model here as well. So which is gonna be a new class, and let's put it into the model package here. Let's call it as product here as well. Okay, because we will be if you remember, even in our Angular and all, whenever we were consuming any data from the API, we used to create models, right? Same as what the API provides us. So here the API is providing us the product. So that is why I have created a product here as well, where we are going to consume the product in the order service. Fine. So I'll just simply copy paste this all things because it's quite similar to what we have done in the product. Now, the next thing is about creating the controller here. Fine. So the controller for the orders. So let's go ahead and create the controller for the orders. So we are not importing that product, we are creating a new product here. So let's go ahead and create the controller. Now comes the important part in the controller. Let's first put it into the package called as the controller. And now let's call this as the order controller. So in the order controller, first thing is, once again, we will have the annotations, the REST controller annotation, and then we will have the request mapping annotation as well. So let's have the request mapping, and this request mapping will be on the order. Now, what order is going to do? Let's go back here. The order is going to consume the product service. The product service is running on what port? The product service is running on http colon slash slash localhost colon 1111. So this is the URL on which the product service is running, and that's the URL which my order service has to consume because it's a consumer, right? So the provider is providing me some data on this URL, and that data has to be displayed into my order service, right? So that's it. That is what we are going to build now. So for that, we require a REST template because a REST template is a Spring class that is used to call another microservice. Now, first we need to create the bean for this REST template to use. So in Spring Core, if you remember, we talked about the bean creation, right? So let's go here and create the REST template bean. We know that to create a REST template bean, we are going to create a method that returns us a REST template. So let's say public REST template, and let's call it as maybe a REST template or get REST template or something. Okay, so I have created this method, and in this method we need to simply return what? Return new REST template here. Fine. So let's do that. Simply return new REST template. So REST template from Spring Framework, and to call it as a bean, we know that we can make use of a bean annotation. So if you are unaware about this bean annotation and creating the beans and all, so I request you to again go back to the core Spring things that we have discussed in the Java full stack course, and from there you can get to know what for this @bean annotation is used. Okay, so let's go back to the order controller now. And inside this order controller, what I'm going to do is the REST template that I have created in the main class, I'm going to auto wire that. So simply create a property private REST template, and then call it as the REST template itself, and we are going to simply auto wire this. Okay, so obviously there are better ways of performing auto wiring, that is auto wire constructors and all needs to be taken. So those are the things that we can implement, but just to make things easy here, so I'm creating a REST template auto wired. Now once this is done, now what is our work? We have to consume the product service which is running on port localhost 1111. Okay, so for that, once again I'm gonna call it as, let's say, get order, and this method, the get order, is going to return us the product, right? So it is going to return us a response entity of type product. Okay, so response entity of type product is what it is going to return us. So we will write that, and let's call this as public, and this is again gonna be a get mapping, so we will call it as a get mapping. Now we have to not simply return a new product and Royal Enfield and all that, because we don't know what that service is going to return to us, right? So since we have written both the services and it's just a static data which this service is returning, we know that it is going to be Royal Enfield. But when things happen in real time, we would not be knowing what object is being returned by the provider service. Okay, so first thing, I'll just say system.out.println, we are calling which service now? The order service. Order service calling the product. Okay, so for the communication, So order service is calling the product service. Now how do we do that? How do we call it? So first of all, we know that it is going to return us a product. So initially, before returning the product, what we are going to do is we are simply going to go for the REST template, because the REST template class is something that is used to communicate between the microservices. That means this class itself calls another microservice here. So I will just say get for the object. So you can see that there is a get for entity, there is a get for object. So as for now, I will just use the get for object. We can use the get for entity as well, and we will see the details about what is the get for object, what is the get for entity, and all that. Okay, so as for now, you can see that the get for object takes two arguments. One is the URL from which the object is coming up, and the second one is the type of the object. So the URL, we know that it is going to come from http colon slash slash localhost colon 1111. So that's the URL for the product here which we have executed, right? So the same URL we are going to write in there. That's the same URL which I have written here. Okay, so once that is done, we know that get for object, it is created generic that returns object by default. Now we have to tell what type of object we are getting from the API. So we know that it is going to return as a product type of object. So I'll simply say product dot class. That's it. So this is now going to return me a product. So product is equal to, now this product is nothing but the product that is returned by the product service. So whatever the product service returns is now stored in the product, and that is something which I want to return when somebody calls the order service, right? So for that, we know that we have to simply do a return new response entity of type product. Okay, and which is going to give us what? It is going to give us the product that we have just now taken from the REST template, comma, the HTTP status is gonna be okay now. Okay, that's it. Let's just save it, and let's now run the order service as well. But before you run the order service, very important part is that you should let your uh, product service running. And for the order service, I may or may not change the port number now. That is because this can now run on 8080, but still I'll come up here and then change the server dot port, and let's us make it 2222. That means order service is running on 2222 port, whereas the product service is running on 1111 port. So for this order service to call the product service, very important is that the product service should be running. So first we will test whether the product service is up and running or not. So you can see that the product service is up and running fine. Now what we are going to do is we will check the order service. The order service has to give us the product service. So 2222 slash order, right? So that's the URL on which the order service is working. So let me just get a confirmation about the same in the controller. So we'll just test it once in the order controller. You can notice that for get I have not given anything, so it will be slash order on which it should call the uh, Royal Enfield here. So let's hit send, and it first says the connection is refused. Let's first check what's the issue here. So http colon localhost 2222 slash the order. Let me check first whether the order service is called or not. The product service is called. The product service is called. Yeah, we did not execute the order service, so let's run this first. So run as the Java application. Now there will be two services running for us. You can see that when I do a drop down here, the order service is running and the product service is running. So here the order service is started. You can see that the order service is started on this particular port, that is 2222, and the product service is also running. You can see that here the microservice product, so which is running on port 1111. Now let's go to Postman and now hit the 2222 slash order, and when I hit this we are getting an exception. First let's see what is that exception for. So we were expecting it to call the product service. Let us first check what is the exception there, and we will resolve that particular exception. So it says HTTP client error exception, get request for localhost 1111 is not found, status 404, the path slash. Okay, so let's see what is the issue with this. Maybe the URL that we have written could be wrong. So let's go ahead and first check that and see how things work there. Okay, so you can notice that here it is slash order has to be given, and here it is slash product. So I might have missed out that in this URL. Yes, so slash 1111, so it should be slash product. Okay, let's save it, and I'll go here, and I will only terminate this order service first. Let's just terminate this and see whether one gets terminated and next one is running or not. So first I will run back the product service and test if my product service running. Yes, the product service is running fine. Now the order service, once again I will run this. Okay, run as Java application. So now the URL is correct. So previously the URL was wrong. Let's again, once this gets started, the order service gets started. What we will do is we will test that started on port 2222, and this is the product which is running. Let's go to the order slash order. Let's hit send, and there we go. We get the product. So this is how we created two microservices here, the product microservice and the order microservice, right? So the product is the provider which is providing the data on slash product. Okay, so whatever product is provided on this URL, it is consumed by the order service here. So order service is getting the exact same product which is actually created in the product service. So this is how we can create microservices, and we can let the microservice communicate with each other. So in this example, we have created two microservices, the order service and the product service. So order service does not have the product data. The product data is actually coming from the product service. So the order service calls the product service using the REST template. The product service returns the data. Order service sends that data. Uh, it can send that data anywhere. That means it can display that data and can work with that data. Okay. So hopefully you have enjoyed this particular session. In the next session, we will be talking more about the things that we have used here and the problems that might occur when we use a static URL like this and all. Okay, so and also here it is only returning a single product. It is possible that it can return more than one product. How are we going to consume the list of products that is returned by that API and all? So we will see that in the next session. Hope you are enjoying in the session. If you are enjoying in the session, do comment and share the videos with your friends so that I'm encouraged to create more such contents for you. Else, if there are not a lot of views on it and if it is not engaged, then it actually creates a doubt in my mind also that the time that I am investing here is helpful or not. Okay, so hopefully you're enjoying in the series. If you're enjoying it, do comment and share the videos to your friends. Thank you. Stay tuned.